Yes, Alina, am I audible to you? Is it audible, Alina? Okay. See now, we were discussing the circular motion, and one portion was left. So before the next class, because in the next class I want to start with proper work, energy, and power. So for that portion, I wanted to complete this chapter, and this couldn't be completed yesterday. So that's why this extra class is arranged just for today. We'll not be having another extra class before Saturday. We'll be just having a normal class on Saturday and Sunday. It's just that this class is there so that we can complete this banking of fruit. Because here there are derivations also. It's not like that we just have the formulas that I could tell you on Saturday itself. So I wanted to start freshly from work energy part. That's why we are having this. And one more thing, because circular motion portion, we are doing it cumulatively. It means all the portions which are included in the circular motion, we are doing it here. Major portion of your rotational motion, a good amount of your circular motion from work, energy, and power, and a lot of motion from your laws of motion. Like the portion that we have started, dynamics of circular motion, that is actually a part of your laws of motion. So only that was to be completed, but it's better if we have completed the entire circular motion in one go. So you also have all the notes at one place together, and it's easier for you also to correlate the things which you would have not done if we have not written the things together. All right. One more thing, let's revise quickly what we have done in the last class. So we had started with the safe limit. What is meant by the safe limit? I have told you that you have a curved track, curved roads are present. Curved roads are present because these curved roads are actually a portion of the circular road. Entire road is circle, a complete circular road we have. So if you take a small portion of that circular road, that becomes your curved road. Okay. So curved road you have on that vehicle moves. Now for every vehicle, whether these are categories of the buses, or we are talking about the small cars, or we are talking about the cycles, or we are talking about the huge trucks that are moving. Every vehicle has its own safe limit, which is the speed limit. If that speed limit is exceeded, if it is crossed, then the car has the tendency to slip away. Slip away means slip out. If this is the curved track, so it will have a tendency to move out. Now, why? The reason is the centrifugal force which is acting. Centrifugal force has two characteristics. One, it is along the radius. So this is also along the radius. But the issue is that this is away from the center. So that's why this tends to move away from the center. Okay, so if it is moving away from the center, the car will be slipping or sliding. Now, if it was a plain road, then this wouldn't have occurred. Because when a curved road is present, the car has to be maintained and balanced towards the center of the circle. That's why we are having the issue of the safety limit and speed limit. On the normal straight tracks we have, on the normal roads we have, the vehicles have their own speed limit, but that is just to prevent the accidents, right? Cars shouldn't move at this speed, buses shouldn't move at a very high speed, trucks shouldn't move at a very high speed. So that is the reason. But this particular safe limit which we are discussing, that safe limit is particularly for curved roads. Okay. Now, let's start with this. Certain derivations are there in your syllabus which you have to follow and which you have to remember. So simple bending of road. Okay, the simple bending of road. So what all things occur? I've already drawn the diagram. There's a curved road. There's a vehicle in the center of that curved road. Now, because it is in contact with the ground, that is the road, that is the floor. So a normal reaction goes upwards. Weight, which is the gravitational force, that acts downwards. So along the y-axis, the normal reaction is being balanced by the gravitational force, right? So N is equal to mg here. Then let's come to the horizontal portion. Okay, vertical is done, normal reaction is there, mg is there. Let's come to the horizontal portion. outwards centrifugal force will be acting. Now again, I have told you centrifugal force is also not an actual force which is present. It's a requirement, it's a demand. So any force that acts along the radius and away from the center fulfills this demand. This means the criteria of centrifugal force or centripetal forces are fulfilled, and these are provided by the already given stated forces which are already existing in nature. So we need not focus on what is exactly the centrifugal force or what kind of nature it holds, because that nature is already predefined. This is not a new force which is existing. It doesn't have its own physical entity present that you can experience. If it is being experienced, it is due to another force which is disguised as a centrifugal force. All right. So centrifugal force is outwards. Now, centrifugal force will be pulling the car away from the radius. Away from the radius, as in along the radius, away from the center, outwards. That is, it will be slipping off. So, whenever a vehicle moves in a particular direction, whether it's slipping, whether it's just moving straight, frictional force has a tendency to move away. So, centrifugal force is acting outwards, whereas frictional force is acting inwards along the radius. Now, out of all these, what do we have to check? We have to check which force is acting along the radius and which is acting along the radius and towards the center, not away, which is acting towards the center. You tell me, out of all the four forces which are available, which force do you think is acting, is fulfilling this criteria? Out of all these forces, N, mg, centrifugal force, frictional force, which is acting along the radius of the circle and towards the center, Alina? You're not audible. Just text, Alina. Just text. Yes, Alina, your answer. No, it is not mg. Mg is acting downwards. Look at the frictional force. It's the frictional force. See, the center must be here somewhere. If this is the portion of the circle, center must be here somewhere. So this is acting towards the center and along the radial path. Radius is this. So you should be confused between these two forces. You should have been confused between these two forces, not these two. These are not along the radius. If this is a circle, these forces are like acting like this: frictional force and centrifugal. Mg and normal reaction are acting like this. So it's friction. Now, what have we studied? mv square by r is the formula for centripetal force. Frictional force is mu n. Normal reaction is mg. So we can put it here. So mv square by r is equal to mu mg. Velocity is equal to under root mu r g. So this is the velocity, which is the safe limit. This is actually the safe limit. And what is r? R is the radius of the track. Mu is the coefficient of friction. Coefficient of friction. Write it.
Ma'am, can you scroll down? I'm done. $20 meters per second.
See, a car is moving on a circular track of radius 100 meters. Mu is 0.4. So safe limit is under root mu r g. So mu is 0.4, radius is 100, g is 10. So this is equal to, this is 4 due to this 10, and this is 400. So this is 20 meter.
Ma'am, is it root 2 meter per second? Ma'am, is the answer root 2 meter per second? Ma'am, are you there?
Now am I audible, Alina?
Yes, ma'am.
Okay. Yes, share your answer with me.
Ma'am, is it root 2 meter per second?
Okay. See, we on a rainy day, coefficient of friction decreases to 0.2. You have to calculate the safe limit. Means V is equal to under root mu R G. So under root mu is 0.2, radius is 100, this is 10. So it is under root 200. This only you must be getting root 10 root 2.
Yes.
This is your answer?
Yes.
Okay, good. It's fine. Now we have a next topic, which is banking of road. Now let us understand what is the meaning of the term banking of road. Right now we have discussed the simple case where we have a circular track, vehicle is moving, and what are the forces which are acting on it? Frictional forces acting, centrifugal forces acting, normal reaction is occurring, gravitational forces acting. Then we have a concept of banking of road. Usually in banking of road, what happens? The vehicles are elevated. Why? Because the road is being inclined to a certain angle. Like in this case only you can see. This is the inclination which is present. This way it has been inclined to certain angle which is theta. Now you have already studied the problems of inclined plane. So how do we resolve it? We have two things, two components by which we resolve it. One is along the radius, second is towards the center. So this is the curved path which is present. This is the inclined path which is present, and this is the angle which is theta. Now the road has been elevated. This is the certain height which has been predefined so that the vehicle can be exactly elevated. Now, how is this calculated? Due to the angle, whatever is the angle, it is calculated in that way. Now, you have a car. Cars will be moving in a circular pattern, but a little upwards, slightly inclined from one side, and most probably from the side which is outwards, which is pointing to outwards, which is not towards the center, which is outwards. That portion will be elevated, and the other portion will be a little declined. So this portion is raised, this is declined, and this is the manner in which the car will be moving till the point the banking has been done. Banking means you have raised the road to certain angles. So now this is the car which is present. This is the angle which is present. Again, initially when the road was just curved, vehicle was present. So normal reaction was straight due to the contact. Now if I incline this, if this becomes the surface, now here is the vehicle. So this normal reaction which was supposed to be this now is this. So this is the normal reaction over here. Downwards we have mg. Now again centrifugal force has the tendency to slip away. So it will be moving away and the frictional force will be along the plane track. This will be the frictional force. So if centrifugal force is outside, the frictional force is towards the center. All right. So it's like this downwards we have the mg present, away outwards centrifugal force, and along the radius we have the frictional force. Okay. Now what we are going to do? We are going to resolve the vectors which are present. Now in which manner, how do you resolve the vectors? You resolve the vectors in two portions. First portion is the normal reaction. Second portion will be the frictional force. Why? See, we resolve the vectors along the radius and towards the center. Now, if you have the frictional force, the direction which is pointing along the radius, this will be, we'll call this as the n sine theta, f cos theta component. And the other portion, which is pointing a perpendicular, that will be f sine theta, which is acting downward. So frictional force, this is theta. Why is this theta? Because these are alternate angles. So frictional force, so this is f cos theta, this is f sine theta. Similarly, this is the normal reaction. This is the angle. So this becomes n cos theta and this becomes n sin theta. So like this, you first have the resolution of vectors done. So it should be clear to you how have we resolved the vectors, in which manner we'll be solving the quantities. Now what we are left with? We are just left with the balancing of the equations. So let us balance the equations. So frictional force is providing us here the necessary centripetal force. So it is mv square by r in this is providing us the necessary centripetal force. So which all forces are acting along the radius and towards the center? Alina, tell me in the chat column. Take 2 minutes. Tell me which all forces are acting along the radius towards the center.
Ma'am, F cos theta and N sin theta.
Perfect. N sin theta plus F cos theta. N cos theta plus F cos theta plus N sin theta. Because these are the forces which are acting along the radius and pointing towards the center. So you can conclude that mv square by r is equal to N sin theta plus F cos theta. Now let's do one thing. Let's put the value of frictional force also. So mv square by r is equal to N sin theta plus mu n cos theta. From here, let's take n common. So we are left with sin theta plus mu mv square by r. Okay. Now what we are left with, we'll find the value of n cos theta. N cos theta is balancing what all forces? N cos theta is basically this upward forces balancing F sin theta and mg. So N cos theta is actually equal to F sin theta plus mg, because these are the things which are acting along y-axis. So when you divide these two equations, mv square by r divided by mg, n mu cos theta plus sin theta divided by n Yeah, Alina. So this is cos theta minus mu sine theta. So NN gets cancelled, M gets cancelled. So V here is equal to RG mu cos theta.
Ma'am, it's V square, right?
So this is what? This is not V, because I'm putting the root of value also. So mu cos theta plus sine theta divided by, what are we left with? Cos theta minus mu sine theta. So this is under root. Now, if you divide the entire equation with cos theta, you will get RG. This is mu plus tan theta divided by 1 minus mu tan theta. If you divide the entire equation with cos theta. So this is actually the formula of the speed limit. So this is actually important. Write down the derivation.
Ma'am, done.
Why did you write it before, Alina? Now you will be solving all the questions which I'll be giving. It means you were not listening while I was.
Ma'am, done writing. Ma'am, ma'am, you're muted.
Now, see, wait, Alina.
Ma'am, actually, I
Say.
have to go.
Yeah, say.
Ma'am, actually, I have to go. Today is my friend's birthday, so like I have to go now.
But the portion is not completed, Alina. At least wait till 7:30, 10 minutes. It's not even
Ma'am,
1 hour right now. So just wait for 10 minutes at least. Let the portion be completed because it's the last portion. I think you can wait for 10 minutes. So in bending of cyclist, you have the normal reaction which will be tilted, because when you take a turn, when you take a curve, normal reaction gets tilted. So when you resolve it, this is n cos theta above. Here you have n sin theta. So mv square by r will be equal to n sin theta. N cos theta will be equal to mg. Now you can take the ratio.